हेलो हेलो
यस सर।
आवाज आ रही है ना? जस्ट वेट करो।
यस सर।
Okay, so just let's start. Okay, so this is the mathematical equation for the EMF induced in the DC machine. Okay, that is K phi omega. K equal to nothing but the machine constant, that means Pz by 2 pi. Okay, where the number of conductor is Z and P is your number of poles of the machine. Okay, and A is your number of parallel path. So if motor run at a constant speed, so we can say that the EMF induced in the generator is directly proportional to the flux, is not? If flux increase, then EMF induced is also increased. So we just try to see their variation of this EMF induced with respect to this flux. That the flux is nothing but the directly proportional to the field current. Okay, so we can say that the EMF is directly proportional to the field current. Okay, so we already discussed their connection diagram for the separately excited, and if suppose that machine is DC shunt generator, so this field coil is connected in shunt with this armature coil, is not, for the generator, and all the prime mover part will be same, doesn't matter either the separately excited or DC shunt generator. Okay, so their characteristic we can see that the if field current not supply given to the generator, then the variation of the field current, and EMF induced will be just look like this one. Okay, so this graph is for the no load characteristic, or we can say that the magnetization curve of the generator. Okay, so along the y-axis we taken as the EMF induced and terminal voltage, and along the x-axis we consider as the field current. Okay, at the constant speed and armature current, we just draw this characteristic is for the load characteristic. Okay, and this one is for the no load characteristic, and do not apply any load on the generator. Okay, so what we observe from this characteristic, that if at this point suppose that field current is 0, but still some EMF will be induced. So anyone just tell me why this EMF induced at the this point? That means when field current are not given to the field winding. So start from this point, some amount of voltage induced across the armature coil. So this EMF is induced due to the residual magnetism in the generator. Okay, so when you increase the field current, so this EMF induced is also increasing. Okay, and after a certain point when the saturation achieved, okay, that means if you increase after the saturation point field current, then EMF induced do not change. That means EMF induced becomes the constant. So after this point, saturation will be achieved and EMF induced is your maximum. That means how much this voltage is EMF induced is almost 125% of the rated voltage of the generator. Okay, so with the help of this experiment we can draw this characteristic. Okay, तो ये characteristic को draw करने के लिए हम लोग को क्या चाहिए? if you want to draw this characteristic, no load characteristic, so what we will data required here. That means one is your EMF induced and another is your field current. Okay, so you have to take the data of EMF induced versus the field current, at least 5 to 7 or 6 to 7 reading, so you can draw this characteristic. So is it clear to all of you, or have any problem? Hello. And this characteristic is for the load characteristic. So just tell me, have any problem with this experiment, either no load characteristic, how we can perform on the separately excited or DC shunt generator?
No, sir.
Okay, so can you perform this experiment? Can you compute the connection on the simulation? At least just try to see here. हम लोग क्या क्या करना पड़ेगा? सबसे पहले हमको समराइज करो जितना भी हम लोग अभी डिस्कस किए. If you want to perform this experiment, what component we required? Just tell me. What are the various components required for perform this no load characteristic of a DC generator or DC shunt generator? You can perform any types of experiment either on separately excited generator or compound generator or characteristic we can. So at least try to discuss here one generator out of those three. Okay. So what experiment we required to perform this experiment? Just tell me. रिस्पॉन्स नहीं कर रहा है. हेलो. हेलो.
Yes, sir.
कैसे परफॉर्म करेंगे हम लोग?
Sir, voltmeter, ammeter, field current, and armature EMF.
सर्किट डायग्राम तुम लोग कॉपी में नोट करो, ठीक है? उसके बाद देखिए हम लोग इसका परफॉर्म करेंगे सिमुलेशन पे. सर्किट डायग्राम सबसे पहले ड्रॉ करो तुम लोग सर्किट कॉपी में. जनरेटर पार्ट का तो यहाँ पे सर्किट डायग्राम इसको ड्रॉ कर लो पहले, ठीक है? लोड कैरेक्टरिस्टिक के लिए अप टू दिस पॉइंट. और if you want to going to connect this is shunt generator, so just you draw this field winding here in shunt of this armature winding. सर्किट डायग्राम पहले ड्रॉ करो कॉपी में, उसके अनुसार से हम लोग कनेक्शन करेंगे. So just draw the circuit diagram. कॉपी में ड्रॉ किया सब?
Yes, sir.
ओके. कौन सा ड्रॉ किया? कंप्लीट सर्किट डायग्राम ड्रॉ किया? प्राइम मूवर का भी ड्रॉ किया या सिर्फ जनरेटर का?
कंप्लीट सर.
कंप्लीट डायग्राम ड्रॉ किया ना. तो जस्ट क्या चाहिए हम लोग को? पावर सप्लाई पॉइंट चाहिए, एक प्राइम मूवर चाहिए जिसका कि हम लोग यूज कर रहे हैं, सपोज दैट डीसी मोटर, एंड जनरेटर का पार्ट तो यहाँ पे दिया हुआ है टोटल कनेक्शन. जस्ट यू मे बी कनेक्ट दिस फील्ड वाइंडिंग इन शंट विद दिस आर्मेचर. ओके. and one voltmeter in parallel across the armature terminal, and one this emitter is connected in obviously in field winding for the measurement of field current. Okay, and towards the prime mover side, one DC motor required, DC motor. Okay, and source. So just try to complete this one. Okay, so just you try to complete on the simulation basis. Just wait 1 minute. Okay, so we are on the virtual lab. This is government of India here. So this side you may find out some this type of lab in simulation model. Okay, so we are going to perform today this one to study the magnetization curve of the DC shunt generator. Okay, so just click on this one. Okay, so first one is your aim of this experiment. So aim of this, what is the aim of this experiment? To study the magnetization curve or no load DC shunt generator. Draw the, we already discussed that, means between the armature voltage and field current, or this one is your EMF induced voltage, okay, with respect to field current. So theory portion we already discussed, is not. So anyone, if you face a problem in theory portion, just tell me. Otherwise, we will go for the simulation and connection of this experiment. Okay. So we will move to simulation part. So next, go to the procedure for this experiment. Okay. On this simulation model, you may find out various components provided on the panel. Okay. So first, you have to concern about this connection procedure. Okay. In part 1, okay, make the correct connection. Okay, that means MCB negative to rheostat 1 and MCB negative to motor, that means a prime mover that is coupled with the generator. Okay, so motor A2 and MCB negative to motor field current F2, and connect MCB positive to the starter L, point L, and connect a starter A to motor armature coil A1, and connect starter F to rheostat F2, and connect rheostat 1 to motor F1, and connect voltmeter 1 to generator A3, and connect voltmeter 2 to generator A4, and connect armature emitter 1 to generator F3, and connect emitter 2 to generator F4. Okay, so this is the polarity of the prime mover as well as the rheostat and MCB supply given through this MCB, and a starter point. Okay, a starter. I think are you familiar with the 3-point starter also in DC machine? So for any DC motor, we required the starter. So that starter connection and motor field winding and armature coil, you have to follow this procedure, what you are given in part 1. Okay. And in part 2, step 2, that means click on the check button. If your connection is correct, then signal so on the screen, so that you can move to the performance for this experiment. Okay, so this is your panel of the no load characteristic of the DC shunt generator. Okay, so you may find out all the polarity of this emitter, voltmeter, and starter, and motor generator part. Okay, so connection is given to you. Just follow this procedure of connection. Okay, and next point, just this is your 3-point starter for the starting of DC motor, okay, shunt motor. So we also use here DC shunt motor as a prime mover for the DC shunt generator. Okay, so this is your MCV. Okay, so positive polarity and negative polarity. So from the positive polarity, go to the L of the 3-point starter, and from the A point, go to the motor armature coil A, this one. Okay, and from F, go to the rheostat, this point, and from this point, again go to the field winding of the motor. So this part is your for prime mover, as a prime mover of this DC shunt generator. Okay, this part is your DC shunt generator mechanically coupled with the DC shunt motor, so that EMF will be induced in this generator. That EMF can be measured with the help of this voltmeter. Okay, and field current of the generator can be measured with the help of this emitter. Okay, so the measurement of voltage across this armature coil of the generator, you just connect this voltmeter in parallel with this armature coil. So take the terminal 1 of this voltmeter to armature of this A3 point of the DC shunt generator. Okay, and from this 2 terminal of the voltmeter connected to the A4 of the generator. Okay, so if connection is your correct, then you just click on this check button. Okay, if your connection is correct, then you will show here signal on the screen. Yes, your connection is correct, so you can move for the performance of this experiment. And if you switch on this MCB, then power will be available here. Okay, and your motor will start to run. So corresponding to that, generator also run, because this generator mechanically coupled with this motor. Okay, so you may be change this field current of this motor. Okay, so if you change the field current, that means obviously you are able to control the speed of this motor. Okay, corresponding to that, you may be able to control the EMF induced in this DC generator. Okay, DC shunt generator. And if you increase the speed, so your obviously EMF induced is also increased. So we just try to perform this experiment. Okay, so have you take the screenshot of this connection? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so just take the screenshot so we can connect corresponding to this, or either you may be familiar how we can connect the 3-point starter with the motor and supply. So you may be obviously, this is a very simple connection of the DC shunt motor. Okay, and mechanically couple that DC shunt generator. So can we move for the, or you just follow whatever the procedure given here? Okay. So if your connection is wrong, something suppose like this one, you may be correct, then on the screen your signal, if you click on this check button, then some signal show like this one, that means your connection is wrong. Okay, you cannot connect to something like this one, that means this negative polarity of the MCB is connected to the positive polarity. Okay, and this L and A are just connected through the rheostat. So this is the wrong connection also indicated here. Also show you to you how we can connect the DC shunt motor with the 3-point starter and supply. Okay. So if your connection is correct, then here signal becomes as your connection is correct. Then move to the performance for this experiment. Okay. Next, fourth step is your, if the connection are correct, then click on the MCB switch to turn it on. Okay, that means if connection is correct, then just click on this button MCB. So just to show you as a green signal here. Okay, that means power is available at the 3-point starter. So your motor will start run. And if you next step, fifth one, that means move the slider on the rheostat to take observation from voltmeter and ammeter. At every instant, when you move the rheostat position, corresponding to that instant, you have to note down the voltmeter and ammeter reading. Okay, suppose that at this point, rheostat position is here. So if you move at this point, then at this point, you note down the voltmeter and ammeter reading. And again, if you move to up to this point, then at this instant, you have to note down the voltmeter and ammeter reading. So you maybe take various reading, that means 6 to 7 reading or 5 reading. Up to this point, you can change the position of this rheostat, and corresponding to that, you just note down the voltmeter and ammeter reading. Okay. And just click on the table. So can you so here the observation table, that is voltmeter and ammeter reading for the various rheostat position at the various rheostat position. Last point is your which one? Move the slider on rheostat to take the observation from the voltmeter ammeter reading, same things. Okay, this is indicate here how we can move the this rheostat position from this to this one. Okay, indicated here, that means move the rheostat slider to take the various reading, that means EMF induced and field current. Okay, and sixth one, add to table. When you take the reading at the observation table with the help of observation table, if you click on the add table, then you just note down in the form of table here. Okay, so you may be observe like this one. Okay, like this one, at the various field current of the generator, you may be get the value of different type of EMF induced value of the generator. Okay, so you may be observed that at the 0.2 EMF induced voltage is how much? 120. At 0.18 EMF induced voltage is 120. So when field current is increases, EMF induced is increases. Okay, we already seen with the help of mathematical equation also. So इस तरह का टेबल तुम लोग कंप्लीट मिल जाएगा यहाँ पे जस्ट क्लिक करने के बाद. सो इफ यू click on the plot graph, okay, last one, that means when at least 6 or 7 observation reading are taken, then click on the plot graph button to make the graph. Okay, so if you click here on the plot graph, then you maybe got the variation of EMF induced versus field current graph on the screen. Okay, so just like this one. Okay, so this is the graph variation. You may be observe here along this direction taken as the field current y-axis. You may be consider field current taken as the x-axis, and doesn't matter. Okay, and EMF induced along the y-axis. So your variation graph something like this one. If you taken as the EMF induced along the y-axis and field current along the x-axis. Okay. So is it clear to all of you? एक्सपेरिमेंट हो जाएगा हम लोग का ये. हेलो,
Yes, sir.
जस्ट ये ऑब्जर्वेशन टेबल हम लोग को ऑब्जर्व नोट करना है और जस्ट ड्रॉ दी variation of EMF induced versus the field current. Just next one, just we will move to performance for this experiment. Simulation. Okay. Okay, so this is the blank panel for this experiment, and now just you give me connection direction how we can connect and perform this experiment. So I start from the MCB and just try to connect all the component of this experiment according to your circuit diagram, whatever we already seen few minutes earlier. So I start from the MCB and connect the first one starter of the 3-point starter. Okay. This complete the prime mover parts and also complete the alternator, sorry, generator part, this one. So how we can start? Just from which point? If we consider them from start from MCB, so just this positive terminal of MCB, here it will go
L, sir.
L. So just take from this positive terminal of MCB to the L. Next.
Negative terminal rheostat 1, sir.
नेगेटिव टर्मिनल ऑफ रियोस्टेट 1 किस पॉइंट से जाएगा? नेगेटिव पॉइंट एमसीबी का नेगेटिव से ना?
यस सर, एमसीबी का.
जस्ट यहाँ से एमसीबी का नेगेटिव दे दिए. नेक्स्ट.
नेगेटिव से सर मोटर का A2 और उसका F2 में से.
नेगेटिव से A2 और F2.
जी सर.
A2 and F2. So negative of MCB is not. So just connect this negative of MCB to A2. That means this one indicate this point and this point for the armature coil, and this point is for the field coil of the motor, is it not? So next is negative point to F2. Next.
स्टार्टर का A सर A1, मोटर का A1 से.
स्टार्टर का A1. स्टार्टर. नेक्स्ट.
स्टार्टर का F रियोस्टेट 2.
स्टार्टर का F से रियोस्टेट 2. Yes. Then
रियोस्टेट का 1 सर F1 से, मोटर का F1.
रियोस्टेट का 1 to मोटर F1. So I think prime mover part is completed, is not?
Yes sir.
Prime mover part, that means motor part, we already completed. So what we will do for the generator part? What we will do for the generator part? मेन तो हम लोग का ऑब्जेक्टिव जो है जनरेटर पार्ट में ही है ना. जनरेटर पार्ट का आर्मेचर वोल्टेज मेजर करना है एंड फील्ड करंट मेजर करना है, नॉट? सबको बोले थे ना कि कनेक्शन तुम लोग कैसे स्क्रीनशॉट ले लो कैसे कनेक्शन करना है इसमें।
सर वोल्ट मीटर का A3 से सर।
वोल्ट मीटर कनेक्ट करना आर्मेचर coil के across we want to measure the voltage, so just connect the voltmeter across the armature coil. Okay, so
Yes.
terminal 1 of this voltmeter is connected across the armature coil, that means A3, not, and the terminal 2 of the voltmeter is connected with this
A4.
A4. Next,
ammeter 1 to F3
F
sir.
3 से
1 से 3, and from this point to this
F4.
point. So I think is it completed?
Yes, sir.
Not. So just click on the check button. So if your connection is correct, then show on the screen is your connection is correct. Otherwise, so correct. Okay. So if you click on this check button, so here show the signal, that means your connection is correct. Okay. So now we can supply on through this MCB. Okay. So just click on this MCB so that the power is off here, on here. Okay, so you maybe see this one from red one to becomes green one. Okay, so your generator start to rotate. Okay, can you see?
Yes,
Hello.
sir. Yes, sir.
Okay, so power supply given to this prime mover of motor DC shunt motor, and due to the coupling of this motor and generator, your generator is also showing that rotating one. Okay, next what we will do, what is next step? क्या करना है फिर हम लोग को? करना है इसका रियोस्टेट का पोजीशन चेंज करना है. That means we want to change the speed of this motor. Speed, how we can control the speed of this motor can be controlled with the help of armature field current, is not, means flux. Okay, so at this point you maybe click, suppose that add table, so just show you. Okay, so just to move this rheostat position, suppose from this point to this one. Okay, at this point, and just click on the add button. What is happened? You may be note down at this point. That means at field current 0.616, your EMF induced voltage here, how much? Is it visible now?
Yes, sir. 150.
115. So just note down. All our students just make the table. Okay. EMF induced in one column serial number, one column voltage, and in another column current, field current. Okay. Have you make the table, observation table? Hello.
Yes sir.
All of you.
Yes, sir.
I'm not only one or two student response. So just each and every student make the table, observation table, and note down the serial number. So at the reading number 1, the serial number at the field current 0.16, EMF induced voltage here 115. And next, just again increase the field current. Okay. So at this point, 0.18 field current. How much the EMF induced? 120.
120.
Okay, just note down. And again increase the field current. 0.2. EMF induced is your how much? 126.
120.
Oh, it comes in table 4. Maybe it comes in table 4. Again increase the field current. That means 0.23, 133 volt. Okay. Have you noted on this reading at this instant?
Yes,
Hello?
sir.
Okay. So last one, just one or two readings at 0.28, 138. Just note down one more reading. Last one. This one. 0.3. That will connect 0.3. For EMF induced is your how much? 142. Reading complete हो गया ना?
Yes, sir.
Okay. So draw the no load characteristic. Whatever you have to observe the data, the there is in the observation table from the observation table. Okay, or maybe either I can list 6 reading. So maybe list 2. ग्राफ ड्रॉ हो जाएगा ना? हेलो
Yes, sir.
हो जाएगा सर।
हाँ तो इसको तुम लोग जस्ट सबमिट करना है सब, ठीक है, कंप्लीट करके इसको क्लिक करके ऑब्जर्वेशन टेबल ग्राफ रिपोर्ट पूरा कंप्लीट करके और उसको सबमिट करना है। Yes. Okay, so can we stop here or have any query, just ask. Otherwise we stop here. किसी को यदि कोई प्रॉब्लम है तो पूछो, otherwise just we stop here. Hello. हेलो,
Yes, sir.
किसी को कोई प्रॉब्लम है या तो फिर हम लोग स्टॉप करें यहाँ पे?
No sir।
Okay, so can we stop here? Okay, and in the next class we will discuss another things. Thank you everyone.
Thank you, sir.
Thank you, sir.
Bye sir।
Okay.